Hi, my name is Takumi Kobayashi. I'm from National Institute of AIST in Japan. In this talk, I present my work to propose a new loss. CNN is a key technology in various computational tasks. The CNN is so-called data hunger method because we need large-scale training data to train large amount of parameters in CNNs. So the CNNs which are trained on small-scale training data produce poor performance, while in real world there are many tasks which are equipped with small-scale training data. To mitigate the bottleneck of CNN, we propose a new loss formulation to enhance feature representation line in CNNs even on small-scale data. Our proposed method provides a new way to feed features into loss functions, so it is so general as to be applicable to various loss functions, including softmax loss. First, we focus on the process, how the features are mapped into logits. The features are multiplied by classifier weight to produce classified logit, and those logits are summed up across all the feature components to finally produce a logit, which is fed into the softmax loss. So the discriminativity of the final logit can be easily dominated by a few strong feature components through uniform summation. In that case, when a few strong features are around, the loss approaches zeros, thereby stopping the learning. Actually, the CNN trained by softmax loss produces only a few strong features. This is problematic, especially in small-scale training data, which does not provide enough training samples to effectively optimize all the feature components. So in this work, we want to fairly optimize all the feature components for learning highly discriminative feature representations. For that purpose, we group feature components into several groups in order to encapsulate the strong feature components into one group. The proposed discriminative grouping provides such a partition over the feature components based on the discriminativity of each feature component. The proposed group softmax loss is constructed by summing the losses which are computed on each group. By doing so, the group that contains weak feature components provides high loss values to keep learning, while the other strong group stops learning. As a result, our proposed method produces discriminative feature representation where all the feature components exhibit high discriminativity. Thus, the proposed method effectively contributes to feature representation learning even on small-scale data. Interestingly, the proposed method can be viewed from the perspective of adversarial training. The group softmax loss increases the loss, and the discriminative feature grouping maximizes the group softmax loss in terms of grouping. Thus, these processes are regarded as adversarial organization against the standard softmax loss. We applied the proposed method to food 1-1 dataset of middle-scale food classification, as well as Caltech and some datasets of small-scale object and scene classification. The method produces better performance compared to the other loss-related methods. And the CNN trained by our method produces superior performance to hand-class ones on the small-scale dataset, while the softmax loss produces inferior performance to the hand-class ones. Conclusions. We have proposed a new loss formulation to cope with small-scale problems for training CNNs. The proposed method is based on grouping feature components to fairly optimize all the feature components based on small-scale training data. The experimental results on small-scale data shows the effectiveness of the proposed method compared to the other loss-related method. Thank you.